All right. Good evening, everyone. Thank you for joining us tonight. We are going to get started. I know we have some people that are still joining us, but we want to be respectful of your time this evening. And so we're going to go ahead and get started with our presentation. If you haven't signed in, please do so in the chat box. And so this evening, our topic is Brain 101, the brain made ridiculously simple. And I am Kelly Spino. I'm the Chief Organizational Learning Officer for the Transformation Education Institute. And with me tonight is Angelique McCoy.
Good evening. I'm Angelique McCoy, and I'm the Talent Development Coordinator, also at the Children's Guild.
All right, so we thank you for coming. We know that there are some familiar faces, and we're glad to see you back. So if we're ready, let's get started.
So just some quick housekeeping, just to bear in mind and deal with the reality that we are learning from home, which is giving us an opportunity to do things a little bit differently. So we will let you know that this particular webinar will be recorded so that we can make it available for those who are unable to join tonight but have registered so that they can see it at a later date. So feel free to keep your cameras on. It's fine if you're in pajamas and you're drinking that warm cup of coffee or cup of tea. Let's just learn together and have a good time. We're going to definitely be utilizing the chat function. So if you have questions, if you have reflections, or if we're doing an activity, we'd love for you to participate. We also ask that you would mute your audio when you are in a place where maybe you have some background noise so that we can just keep the flow of the learning going and just to enjoy this community mindset, have a good time, and be open to some new ideas. Let's learn about the brain.
All right, so let's get started. The topic tonight is the brain. Love that guy. All right, we're going to start off tonight with a poll to figure out how much do you know about the brain? So in just a second, we're going to pull up the poll and we want to know, where are you in your knowledge of the brain journey? Do you know nothing except that you have one? Do you know a little bit? You know a good amount? Or you're an expert and we should be calling you a neuroscientist? So let's pull up that poll and see where we are with our brain journey. All right, we're getting close there with the responses. And it looks like we have some coming out. All right, we'll just give another second for anyone who hasn't had a chance to register yet. All right, so if you want to share the results, it looks like we have a couple people that say, I know I have one, but that's about it. Don't ask me any questions. Some people say, a lot of people say, I know a little, and that's the majority of you here tonight. Some of you say, I know a good amount, but it looks like we don't have anybody who feels like they're a neuroscientist. So that's okay. Maybe by the end of the presentation, you'll be able to answer that question a little bit differently. So let's get going. All right, so we want to start off with, did you know, and this is kind of a disturbing fact, that we are currently preparing students today for jobs that don't exist. So what that means is that there are so many advances, both in technology and cognitive neuroscience and medicine and all kinds of industries, that we're falling behind. Say, what now? We're not educating our kids to keep up? What? I think we need to take another look at this one. Let's take a look. Wow. When you look at that and see what has changed, over 50 million tweets in a day, astronomical. So what do you think? What will you have to do, to learn, and to be in order to empower your students in this new world? How do we keep up? So what do we do? One of the things we can start with is we need to know your brain. We need to learn about learning and develop the metacognitive skills that allow us to continue our journey of learning as the world continues to change exponentially. So let's take a minute and do a little activity together. We're going to do what's called a Mentimeter. Some of you might have done this with us before, but in the chat box, you will see the link to connect you to the Mentimeter. When you get to this link, you're going to see the question. It says, when I think of the brain, the word that comes to my mind is, and what we want you to do is type in whatever comes to your mind. And then we're going to bring it back and we're going to take a look at what were the trends in when people are thinking about the brain, what are they thinking about? So go ahead into the chat box, click on the link. When you get to the Mentimeter, type your answer into the window and join us back here.
And the thing that's really cool about this word cloud that we're actually forming as we do this activity together is that you'll begin to notice that some words will grow larger, some will have similar colors and size and shape. And those are basically going to be the words that we've all kind of clicked in together. So if we use the same thought, it will begin to expand and we'll begin to see how our brains often think alike. So if you just open up your web browser and you click on that Mentimeter link that's in the chat, you'll be able to see it. And then we'll come back and we'll share it as a group.
If anybody's having trouble or needs help, just let us know. The link is in the chat box, which is right at the bottom of your screen. If you click on the chat, you will see that the link is there. Angelique sent it to the group.
Wonder we can see what that word cloud is starting to look like. Look at that, the power of teamwork. So a lot of us must have said knowledge. That brain gives us knowledge, and then complex, still growing and still moving as we put in our thoughts and ideas. Powerful, magnificent, fascinating. It's amazing how we see the brain to turn a little bit. Amazing. Oh, gray matter and intelligence. And just watch as it moves.
I see supercomputer in there too.
Control room. Oh, I love that. It definitely is a control room.
Miraculous. These are all wonderful words. Sponge. All of our children were sponges all the time.
We've got some educators in the room. I see emotions, impulse control.
And neurotransmission.
Nice.
All right. Well, that'll continue to grow. And maybe at the end, Diane, you can bring it back and share with us. So continue to add to it if you'd like. But we'll continue to see how we use those that you can come up with to help us as we're going through our presentation. All right, so let's get started with Brain 101. The brain made ridiculously simple. So our focus tonight is we're going to talk about 6 major structures of the brain and their functions. We're going to talk a little bit about brain chemistry, and then we'll end the evening on the topic of neurogenesis. So this is a view of the brain. And as you can see, the structures that we're going to talk about this evening include the amygdala, the hypothalamus, the frontal lobes, corpus callosum, the hippocampus, and the cerebellum. So those will be the 6 structures that we will talk about and talk a little bit about their functions as we go through the presentation. One of the ways we like to make the brain simple is by using icons. And the icons are helpful in allowing us to associate a picture cue with the function of that particular structure. And so as we go through, we'll explain to you how the icon represents the function of each of the structures of the brain that we're going to cover this evening.
So let's jump right in and let's talk about the hippocampus, otherwise known as the mail carrier. So when you even think about just the process of the mail carrier, you may be asking, what does that mean? When we look at the hippocampus, where it is located in the brain, it's in that medial temporal lobe, almost in the center of your brain, and it's intimately connected to the amygdala, which we're going to talk about in a little bit. And this particular part of our brain really plays a major role in learning and memory. It looks sort of like a seahorse, as you can see on your screen. So that's also another way that you can remember this part of your brain, the seahorse looking material that's inside of our brains. When it comes to the hippocampus, it's like the mail carrier. If you think of the process of sending and receiving mail, that mail gets sent, and at your post office, it is scanned in so that that information can be retained and then retrieved when it gets to the other side of its destination. And the hippocampus pretty much works the same way. It's the place where memories are consolidated. It's the place where new learning is housed. And it also is important to our spatial navigation and our orientation. And this is because of the neurons that are in the hippocampus that encode all of the information that we learn to help us make better sense of our surroundings, sort of like a cognitive map. And one of the things that we need to remember as it pertains to the hippocampus is that all learning, every single thing that we learn, whether it's something as simple as tying our shoes, to driving a car, to reading a book, to meeting new people, all learning is making a memory. So from now on, when you think about learning, think about making a memory.
All right, so our second structure this evening is the amygdala. And we like to refer to the amygdala as our palace guard. The amygdala is actually, there are 2 of them. There's one in each hemisphere of the brain, and it looks kind of like an almond in its shape. So the function of the amygdala is just like a palace guard. So we know that the palace guard is there to protect the palace from all signs of harm, danger, anything that might disrupt the safety from intruders that could come onto the palace. That's what our amygdala does. It's there to keep us safe. And it's there to make sure that when there's any sort of threat, that it responds with a fight, flight, or flee response. When we talk about the amygdala, we always talk about this, because the amygdala is the part of the brain that activates that stimulus that says there is fear. And so when that palace guard says there's fear, there's several options. The first thing is to just solve the problem that's causing the threat. Sometimes it's a matter of escaping from the threat. Oftentimes we have to learn to cope with this threat, much like we're doing right now with the COVID. Sometimes we have to defend ourselves the best way that we can, but at all cost, we have to survive. And so the function of the amygdala is survival and to keep away fear.
So let's talk about the hypothalamus. The amazing thing about our brain is that each and every organ that we're talking about tonight works together to keep us in our toppest level of high functioning. And so when you think of the hypothalamus, think of a thermostat. Yes, I said a thermostat. Moving on, the hypothalamus is known as the inner chamber because, again, it's in the inner parts of the brain and it's involved with pretty much everything we do on a daily basis: eating, drinking, the control of our body's temperature, and even maintaining a level of energy. The hypothalamus, its goal is to keep us in a state of homeostasis. If you think about, and I'm going to bring up a childhood story that we all know, Goldilocks. You think about her story, and she went into the bear's home and she tried every bowl of porridge, and one was too hot, one was too cold, but one was just right. We might say that Goldilocks found her level of homeostasis with the just right bowl. And so we want to really make sure that we're helping our brains to develop that level of comfort, that the goal is to maintain our equilibrium. Because the hypothalamus, like I said, it affects all of our daily activities, it affects our behavior, and it also secretes hormones like dopamine and serotonin. And so it's really important that we make sure that we are caring for it in the most efficient way. One thing that's very interesting is that the hypothalamus is also responsible for the 4 F's: fighting, fleeing, feeding, and you got it, fornication. These are, when you look back into the subject of evolutionary psychology, these were known to be the personal drives, the motivations, and the instincts that all humans need to survive. And so that part of our body, that hypothalamus in our brain, is what is responsible for the area of these specific motivations. And so when it comes to the release of those hormones from the pituitary gland, this is what causes what we like to call brain chemistry. Cortisol and adrenaline make you feel great or make you feel scared or make you feel nervous or make you feel afraid. And then there's the serotonin and the dopamine that give you those ahs and those yahoos, I'm feeling great. But when we think about brain chemistry, we have to find the right brain chemistry because it's so important to remember that these pairs do not play well together. So let's go to the chat. What are some ways that you stimulate the release of dopamine in your brain? How do you get to that point in your life? What is it you're doing right now, especially in light of where we are in this pandemic and trying to get through day to day? What are you doing to release that dopamine in your brain?
We have some people here with hobbies: meditation, exercise, gardening, watching the sunset, listening to music, walking, praying, walking the dog, connecting with others, helping others, calm music, anything pleasurable, science experiments with my kids, playing with pets, music, silence, these kind of learning opportunities, eating yummy food, painting, scents, a prayer garden, quality sleep, yes, sitting and enjoying the quiet, hugging my grandkids, creativity. These are all wonderful ways of getting dopamine into our system. Favorite TV shows, yes, farming. Wow, wonderful idea. So you all know how to get that dopamine. Now what we have to do is make sure we can keep that dopamine flowing and keep out some of those other things that are causing us stress, such as that cortisol. All right, so let's go on to our next structure. Our next structure is the corpus callosum, which we like to refer to as the Bay Bridge, given that we're in Maryland. So the corpus callosum is located between the two hemispheres of your brain, and it's a thick band of nerve fibers. And the purpose of it is to transfer motor, sensory, and cognitive information from one hemisphere of your brain to the other. It facilitates this integration of information. And so, actually, your right side controls your left, and your left side controls your right. So it's actually just the opposite. And by coming together, that's where logic and emotion meet. Let's take a little closer look at that one. So on the left hemisphere, we tend to think of this side as the logical, thought-based language side. And the right side we tend to see as more of the interpersonal emotional. So people oftentimes say they're either left-brained because they're more analytical, or they're right-brained because they're more creative. But actually, each side is dependent on the other. So let's take a couple of examples. Let's take a look at the motor activity. So if you're learning to ride a bike, the right side of your brain sees the bike and says, wow, it's shiny, it looks fast, I can't wait to get on it. And the left side of your brain is saying, all right, so we have 10 gears and 4 shifts, and we have to make sure that our feet are inside those cups so that we don't slide out. And we have to make sure we start off in a low gear, but then we're going to move to a higher gear whenever, and it's analyzing the process. Same thing with the idea of getting the bigger picture. So on the right side, you'll see face recognition. So this is the person who recognizes and say, that person has a really attractive face. But the analytic side says, I really love your eyes. So they're picking out specific details that they're noticing, and the right side sees the whole picture. And on the left side is where we create our memories. And the right side is where we retain it. And so it's this interaction between the left and the right hemisphere through the corpus callosum that allows us to transfer information and to be whole thinkers, even though we may have a dominance in one side or the other.
So let's talk about the mover and the shaker in our brains, the cerebellum. The cerebellum is actually the only part of the brain that you can actually feel. So if you take your hand, and right now, if you put it behind the nape of your neck and move your fingers up, you'll feel this small mass that you can actually press and kind of rub your fingers around and actually feel it. That is your cerebellum. It is the part of the brain that is not encased in our skull, which is why we're often very concerned when it comes to wearing helmets and protecting that part of our brain, because it is responsible for balance, for coordination, for even timing and force, and even for posture. So we need our cerebellum, that mover and shaker, and cerebellum is Latin for little brain. And we need it in order to play the role in our bodies to get us moving and to keep us moving and to think about our vision and our motor learning. The main part about the cerebellum is that it's really involved in the role of thinking and processing our language and our mood. So there are things that could damage the cerebellum, which is why we are always very, very careful in how we care for it. Thinking about drinking alcohol, let's remember that, for an example, this is one of the things that can inhibit our cerebellum and cause us to have disruptions in our body's coordination and movement. And not only that, there are other factors that can damage it, including our inability to judge distance, when to stop. Our cerebellum also controls a rapid alternate movement. So being able to shift your left from your right, or being able to jump over a puddle of water, or being able to think quickly if something is coming at you, all of that is developed in your cerebellum.
All right, so our last structure this evening is the frontal lobe. And the frontal lobe is actually the last area of your brain to develop. and it doesn't actually fully develop until around the age of 25. It's located in the front of your brain and in the prefrontal cortex, and it's about a third of the brain is comprised of the frontal lobes. The frontal lobe's primary responsibilities are in reasoning, judgment, and problem solving. So, we tend to think of our frontal lobe as a co-pilot. Because think for a minute, our frontal lobe doesn't develop until you're about 25, sometimes into your 30s, according to some new research. And so when we're thinking about our children as developing this frontal lobe and these capacities, we have to remember that they need guidance, much like that co-pilot who's there to guide and support. We have to be the surrogate frontal lobe for our children as they're growing up, because the frontal lobe controls voluntary movements. It helps with sequencing multi-step movements, such as riding that bike or making a sandwich or even getting dressed in the morning. It controls our speech and language production, which is predominantly in our frontal lobes that occurs. Also, a lot of other activities happen in this frontal lobe. Our attention and concentration is located in the frontal lobe. Our working memory. So your working memory is basically being able to hold on to information long enough until you're able to apply it. It's also where your reasoning and judgment occurs, your organization and planning, as well as your problem solving. And that's not all. It's also part of regulating our emotions and our mood. It helps control our personality expression. It controls our motivation, our impulse, and our social behaviors. And all of those together are what are considered part of your executive function. And so the frontal lobe controls your executive function, and your executive functions are what not only make up your personality, but help you to do the things you need to do every single day. And each of us has strengths in certain executive functions, but there's also weaknesses. And so part of teaching children to develop their executive functions helps them to develop the coping mechanisms to deal with the stressors that life produces, and helps them to maintain a healthy disposition and attitude towards life, because they have the coping skills that mediate the pressures of the stress. So I know we talked a lot about the changes, but there is hope for our future. It's not all dim and grim because of what's going on in our world. We do have hope. And there is good news. The good news is that our brains can change for the better, but the environment must be correct and align with the needs of our brain in order for this change to happen. What we're talking about here is the process of neurogenesis. And neurogenesis is the ability to grow neurons. And typically, what was thought of was that neurons were only developed in our children up until about the time you got into your teen years. And after that, you had all you were going to get. And if for any reason there was damage to the neurons through excessive stress or distress or any other condition or injury, then you would be at a loss. But what neurogenesis says is that the hippocampus is one of two places that we can continue to grow neurons even into adulthood. So if we engage in certain practices, we can continue to grow new neurons and make new neural pathways for learning into adulthood. Our hippocampus can be healed. So, neurogenesis was known to regulate our learning, our mood, our memory, and our overall health. even into adulthood. So when your brain does well, you do well as well.
So we'd love to share with you some power tools that you can use to continually initiate the process of neurogenesis in your brain. Eric Jensen is one of the thought leaders who is blazing the trail in brain-based learning and really helping us to understand the power of applying learning how the brain works to learning. And so that first power tool is enrichment, doing things that will enrich your brain, whether it's activities, whether it's reading, whether it's mental games, whether it's crosswords, things that will enrich your brain and continue to spark neurogenesis. And then very simply, sunlight. There is truly something in the power of vitamin D. Getting outside, we know that the sun is going down much earlier now, and we don't have as many opportunities as we may have had in the spring and in the summer. But the minute you see the forecast is telling you it's going to be a sunny day, make some time in your day to get out there and just bask in that sunlight, because it's not only good for your body, it's excellent for your brain. And then, of course, getting sleep. It's so important. Our brains need a specific amount of sleep each night in order to encode all of the learning that we've taken in the day before. And a lack of sleep will cause us not to encode that information, and it will result in lack of memory recall and so many other different things. So get some good rest tonight. And then reduce distress. We all know that there is a healthy level of stress that we all need in order to function effectively and to get to our levels of productivity in our lives. But what's important is that when that cortisol and that adrenaline are elevated ×2, you can get into distress. And so reducing the levels of distress in your life is going to help to spark the neurogenesis. And lastly, very simply, a healthy diet. We could never tell you what to eat, when to eat it, and how to eat it, but we can tell you that whatever you're eating, make sure that it's good for your mind and your body.
So just as much as there are power tools to keep us moving in the right direction, there's also some things that are going to stop the neurogenesis. And we know that stress inhibits the proliferation of new cells. So we have to manage this distress that we feel. And it's not the stress of the little things every day, but it's prolonged, severe distress. The physical inactivity, as you heard, your brain seeks movement and needs movement. It also needs novelty. So the boredom of always doing the same thing really leads us to that same neural pathway that eventually becomes dwindled to the point of not even encouraging you to move on or to learn something new. And of course, poor nutrition. Our diets are so high in sugars and fat content that it really has a negative impact on the development of neurons. But we know that when you eat a good diet, a healthy diet, we can build neurons. So some of the things to think about are dark chocolate, coffee. Yes, coffee is actually good for your brain. Not 12 cups, but a few. Blueberries. Blueberries are great. And foods and fatty acids like salmon are really great for you to be able to build those neurons. So there are some good things to eat that sound like they should be on the naughty list, but are actually really good for your brain. So we have to stick with the power tools in order to avoid stopping the neurogenesis that's happening in our brains. So we've talked a lot about the brain tonight, and in the Children's Guild Alliance, we have what's called the brain path. And recently we had an opportunity to film the brain path and record for you what it actually looks like if you could walk through your brain. And so we're going to share with you a piece of this film that we've created. And interested in obtaining a copy for it, if you put your name and email address in our chat box, we will send you a link to the whole brain path course. Angelique is our moderator. So let's take a look at just one little segment of the brain path and what it looks like.
So let's look at the brain path and let's talk about some parts of the brain. If you look up here, this first part of the brain we're going to talk about is called the thalamus. The thalamus is an inner chamber in our brain. And what it does is it takes all of those individual senses, wraps them into one experience so that you can pull out one memory. So instead of just thinking about the taste of the cookie or the smell of the cookie or even the sound of the crunch of the cookie, you just remember that I enjoyed one really great chocolate chip cookie. Here we are with the thalamus. It creates the experience. Let's move on. In thinking about those senses, you can't forget the nose. The nose smells everything. And each and every one of these colored cords symbolizes one of your five senses. And if you notice, they all integrate together at the thalamus. So that means that your five senses come together to form one memory. Here's another sense that we love, the sense of taste. That cookie, I can still taste it and it's still awesome. But sometimes I eat things that my taste buds don't like so much, like maybe a spicy pepper or maybe the saltiness of a pretzel. Either way, that taste sense is creating a memory so that instead of me remembering just that horrible taste, I remember that I might not like to eat something specific. My memories will then come back to me and the brain lets me know that I want to stay away from anything spicy. It's amazing how the thalamus brings everything together in one.
All right, so that's just a taste of the brain path, and it goes through each of the structures and uses some visual icons to help make associations with what actually occurs in our brains when this is going on. So when we are in the brick and mortar, we would have students come through the brain path and get tours of what each piece looks like. And hopefully when our life goes back to in person again, we'll be able to offer those. But in the meantime, we have a recording of our brain path that helps to visualize and hear what each of the functions of our brain structures does.
So we are coming to the finish line of our wonderful discussion this evening, but we want to hear from you. We're wondering, as you think about 2021, what are some of the topics that you would like to see in future webinars? We like to build and create and tailor our conversations just for your needs, just for the needs of your family, for the needs of your educators and all of your students. So why don't you go to the chat and tell us some topics that you might be interested in learning more about? And those who are wondering, this particular recording will be available. In a few weeks, we will send you an email and let you know when you can access it.
So even if you're here tonight, you will still get the link to watch it again if you'd like to. So it looks like we have some social emotional learning, the effects of trauma on the brain, some autism in the brain. PTSD, absolutely, teen brain and drugs, the brain and depression. And so these are all topics that we work on, and I'm continuously doing research and working with different groups. Anxiety in the brain, absolutely. Epilepsy, information overload. We know what that is too. The brain and the effects from the pandemic, absolutely. So these are lots of really great ideas, and we'll be working on setting up the schedule so that beginning in January, we will continue the third Wednesday, I think it's the third Wednesday of every month, of coming up with new topics for us Of course, you can go to our Brainwaves and see what the topics are, receive a copy of the handout, and tonight you will get a copy of our brain anatomy with our icons at the bottom. So each of you will have a copy of that you'll receive in your email, along with the link to watch this again if you'd like. We thank you for coming tonight and taking the time to share your thoughts and your feedback with us. There are some references that are cited here that are used throughout this PowerPoint. So we want to make sure that we give acknowledgement to some of the research that goes behind our work. And as always, if you have any questions or any feedback or would like to contact us, our information is here. So we invite you to reach out to us if we can be of service to you in any way. We want to wish each and every one of you a happy Thanksgiving. Make sure that you stay safe.
Absolutely.
Some downtime and some time with your friends and family, even if it is by Zoom. So have a safe and happy holiday, all of you.
Take care of yourselves and take care of those brains.